So I'm probably the only children's book author in the building right now, and that is what I do as a profession. I write children's books and illustrate them about the future of the world and a future that is more and more run with technology. And all of this started because I was frustrated with the way computer science was portrayed in the media. It was a lot about these dreary old gray books. And when I was studying computer science myself, I started with a language called Ruby. And every time I ran into something I didn't understand, I would try to make this little character, a girl called Ruby, on the margins of the computer science books to make these concepts of object-oriented programming or, I don't know, like functional programming a little bit more approachable and understandable for myself. And I truly believe that if we think that software is eating the world, like Mark Andresen put it, if code is the next universal language, instead of grammar classes, we ought to be teaching poetry lessons. And what that means is the idea that we ought to be giving code and software and technology much more diverse tool sets and toolkits for the next generation. We don't learn a natural language only by speaking it, only by conjugating the irregular verbs or practicing the grammar rules. We learn a language by using it. And so far, the ways we've been teaching technology have been quite narrow. And it's a surprising thing for me that there were so few new kinds of approaches to teaching technology. There were a lot of puzzles that teach you to code, and there were lots of apps teaching you how the basics of programming work. But there were very few stories. And if I know anything about us humans, it is that stories are the original way we learn. The original way we learn about ourselves, the way we learn about each other, and the way we learn about the world surrounding us. And no one was telling stories about the world of technology. And worse yet, no one was telling hopeful stories about the future of technology. So that's what I do. I write and illustrate and design these books that tell about the magical world of computer science. They've been published in 28 languages, and I'm happy to say that all 4 books, from coding to computer hardware to networks to machine learning and AI, are now out in Latvian, and we'll be selling some books later today. And more, I'm starting to think that what I'm doing is preparing children for a world where computers are in charge of the biggest problems in our world. But it's not the computer scientists of today who will be able to solve those problems. We need a radically more diverse group of people to get excited about computers as a tool of self-expression and as a tool of problem solving. And with that in mind, I also launched this fall a series called Love Letters to Computers. It's a free YouTube series that tells for primary school teachers about the world of computers, machine learning, AI, networks. And it's an effort to make this world that seems very remote and scary for a lot of us a little bit more approachable. So how do you teach these skills if the important thing is not to learn to code anymore? Well, I draw a lot of inspiration from the big names in childhood pedagogy, those of Maria Montessori, Jean Piaget, Seymour Papert, Loris Malaguzzi, and, of course, coming from Finland, Tove Jansson, the mother of the Moomin series. And I think it's really important that for an industry that is so relentlessly focused on the future, we also have the humbleness and the patience to look into the history, because there's so much knowledge that is already out there on the way we humans learn and how to raise kids, that it's a very kind of narrow and self-centered idea that we as technologists would be the ones who have all the right answers when it comes to childhood and when it comes to learning. But at the same time, I wish to make the world of pedagogy aware of these amazing humans that have inhabited the world of computer science. Those of Alan Turing, John von Neumann, George Boole, Ada Lovelace, Claude Shannon. And it's this weird fiction or this weird story we tell ourselves that the computer came out of the sky, that it landed as this beautiful machine that Steve Jobs or Bill Gates came up with the computer. And what I want to talk about in my line of work is how computers were actually made through multiple different generations of humans with very, very different interests and ideas. We needed material scientists, poets, philosophers, math people to all come together. And when you think about it, we can draw a direct line from Aristotle to modern-day computer. And it's this story of computers, how computers are actually about the humans and their big ideas, that I want to be sharing with the next generation. So all in all, I think it's a very exciting time to be working in education and technology. I don't consider myself an education technologist. I consider these two fields to be a little bit separate. But I do think that we need more visions about a future of technology that go beyond only teaching kids what JavaScript is about or what Ruby is about. And again, we can learn a lot from the past. We know a lot about how we decided to start teaching physics or math or biology to children and what are the foundational things behind these disciplines. But we know very little about computer science because as a discipline, it's only 70 years old, give or take. It's only recently that we've started to kind of understand the messy bits and the overlaps of computer science. But we do know that you can't offer an entirely organized intellectual discipline only by offering the children pre-organized vocabularies and concepts. We know that learning is grounded in action. And easily computer science tends to be very abstract. So what we need to do is take the abstract ideas of computer science and make them tangible. And there's this very famous saying that gets attributed to Edgar Dijkstra a lot, where he says that computer science is no more about computers than astronomy is about telescopes. A computer is a tool for problem solving, a tool for self-expression. And we need to start creating a curriculum that makes the children feel like they are in control, that they are creators as opposed to consumers of technology. So how do you then do this? Well, one approach of doing this is taking a concept of, like, say, the algorithm that we adults tend to talk about relentlessly, but we never explain what it actually is. But kids, they know what an algorithm is. They say, oh, an algorithm. An algorithm is a step-by-step instruction to solving a problem. And they know that if you, for instance, practice an algorithm by one person being the computer and one person being the programmer's task is to break a mundane job, like brushing your teeth, into sequential steps of instructions. And they learn that programming requires a lot of creativity, persistence, clever thinking. And they learn that it's not lonely, because there's always so many different ways of solving this problem. First, you need to define what a toothbrush is for the computer to be able to grab the toothbrush. Then you need to take the toothbrush to your mouth and tell the computer to stop moving its hand. Then you remember that, oh boy, the toothpaste is there. And you grab the toothpaste, and you remember that the toothpaste has a cork, and you have the toothbrush in your other hand. So what are you going to do? And the children learn by a very tangible, very real, and very simple activity that computer scientists, they need to think about all kinds of things in the world. They need to work in pairs. It's not a lonely discipline, it's something you do together. There are these lone cowboy programmers, but more and more programmers work in teams where you have multidisciplinary people working together. And even professional programmers, they often do something called a pair programming, where the idea is that two pairs of eyes spots problems better than one pair. They learn that programming is all about persistence. It's all about debugging, about going through your solutions and answers and trying to find the thing that is not working. People often come to me and say, oh, that's easy for you, you're so good with the computers. And I tell them that I'm not good with the computers. I'm just really, really persistent, and I stay with the program longer than anyone else. And finally, they learn that programming is actually more a craft than science. It's creative. And especially in early childhood math, you always have one right answer. Whereas in programming, you can have many different right answers. As many as there are kids in the room, in fact. There's different ways of solving the problem of creating an algorithm to brush your teeth. Because some of them are more efficient, some of them are more easy to update, some of them are more elegant. But as long as the computer program compiles, it's right. And that means programming is highly creative. But this is not enough. If we leave computing and algorithms at this level, the kids will be able to play it out as like an imaginary plaything, but it doesn't help them understand the power of an algorithm. And for that to happen, I show them these 5 numbers, and I ask them to put the numbers in order of magnitude so that the smallest is on the left-hand side and the biggest is on the right-hand side. And depending on the age of the children, it takes them roughly 5 to 7 minutes to do this. And then I ask them to do these numbers, and I ask them to do these numbers over here. And by this point, the kids grumble a little bit. They say, "This takes forever, Linda." And I tell them, this was lesson number 1. You never want to compete with a computer on a task like this. The computer will always outperform you. It will always be faster, more exact, make less mistakes. But it still needs instructions. And those instructions are written by us humans. And a way a computer might approach this task is like this. It would start from the beginning, it would compare 1 and 56, and it would say 56 is bigger than 1. Let's keep it like this. It would compare 56 and 4, say 4 is smaller than 56. Let's swap these around. It would move on, compare 56 to 70. That looks okay. 70 and 20, let's swap these around. And then it would move all the way to the beginning of the loop and keep repeating this sequence of instructions over and over again until the numbers were in order. And this here is called the bubble sort algorithm. It's like a working horse algorithm invented sometime in the 1960s or 70s, still wildly in use in today's industries. And it was created by a human. And I think this is really important, because we need to start explaining to children that computers don't create code. We humans create code, and we need to take ownership over the code we create. So next step, I show the children a picture, and I ask them, where is the algorithm hiding in the search engine? And the kids, they look at this picture for a moment and they say, maybe in the order in which I see the search results. And I say, bingo. That's called a search algorithm, and the most famous one of them is probably the Google one, the PageRank algorithm. And that was written by a human. And then also the ads which you see, those are defined by an algorithm that takes into account your search terms, your browsing history, your location, any demographic data it can guess from you to show the right kind of ads for you. And then we look at the social networking side, and we try to find the algorithms hiding on the social networking side. And we say that, yeah, the ads, those are defined by an algorithm. And I say, yes, there's a little tracking algorithm that follows you around the internet, and it knows when you visit that web store and knows how to show you the right kind of ads on Facebook or Instagram. But also the order in which you see your friends' updates, those are defined by an algorithm. An algorithm, a step-by-step instruction that is designed to optimize the time you spend on the site, so the retention of the website. And it tries to guess who makes you stay longest on the site. So it's going to show you the most obnoxious, the most emotion-filled updates, and also the updates it tries to guess are relevant for you. And then finally we look at YouTube, and by this point the kids are already really, really savvy. They say, oh, the algorithm, it's in the suggested next videos, and also in the autofill when you type something in on YouTube and it tries to guess what you're trying to type in. And I say, yes, those are defined by an algorithm. But more and more also the kind of content we see online, that's designed by an algorithm. Because every 1 minute, there's over 300 hours of content uploaded on YouTube. And there's no way a human can go through all of that, so they use an algorithm to rank and use as suggestions for the videos. And those algorithms can be played. And it means that there's entire content farms that the only objective of which is to generate these weird mashup videos of Surprise Play-Doh X, Peppa Pig, Stamper Cars, Minecraft, Pocoyo videos that completely blow the brains of our children. And this is what I want them to remember about an algorithm. Not only that algorithms are blazing fast, more effective than humans in certain kinds of tasks, that they are step-by-step solutions to problems, but that slowly they are shaping our societies and the ways we consume content and the ways we interact with the world. And those are the levels of an algorithm I want to teach for the children. And it's important and meaningful because these invisible structures are everywhere around our world. And we need to start one by one dismantling these abstract concepts and making them approachable and understandable for our 6-year-olds. And more than learning to code, I'm slowly starting to be interested in the question of what are kind of the foundational skills we should be teaching our children who are going to enter the workforce in 10, 20 years' time. And I think one of the most important things you can teach for a child is what are the things that are easy for a human, what are the things that are easy for a machine, what are the things that are hard for a machine, and what are the things that are hard for a human. And there's a difference between those. And instead of just saying that we need to prepare our children for a future where jobs will look different, what if we started to prepare our future jobs for the children who are growing up today and make sure that they actually feel and fit the skills we humans are excellent at? And those skills obviously change. On Deependexterorg, it's a really quirky little site that keeps kind of tabs of the different kinds of things AI already today can do. So AI can identify you from your walk, it can help predict cancer, it can hunt for subatomic particles. All in all, when you go through this list of things AI can already do, it feels like the perfect sidekick. It feels like Robin to your Batman, it feels like the best work colleague ever. But there's one big thing that is sort of a hindrance to our ability to work with AI, and that is fear. And that is something I think we as an industry need to start tackling quite quickly. I've used a lot of different definitions to talk about technology today, and I think in some ways computer science is the worst thing we can call this discipline because it makes normal people think that computer science is about computers in the same way physics is about studying the physical objects of the world and biology is about studying the biological objects of the world. But let me for a second try to redefine technology through the eyes of this Spanish philosopher who says, José Ortega y Gasset, who says that technology is the production of superfluities, today as it is in the Paleolithic age. That is why animals are atechnical. They are content with the simple act of living. So what if technology has to do with our ability to imagine future possibilities? What if technology by definition has something to do with humans' storytelling abilities? And that's something we as an industry need to start tackling. Here's the thing. Technology already won. We are no longer the rebel alliance, we are the empire. And we need to start taking responsibility over our impact on the world. And we need to start redefining our counterculture underdog story that we are still very fascinated in keeping. Because we need to start imagining plausible futures that are more inclusive, less dystopian, more hopeful, and that include all kinds of people. Because right now, when you go to work, talk with someone who doesn't live in the startup bubble of ours, they hate technology. For them, technology is Black Mirror, it's Hunger Games, it's Facebook, privacy, Google, all of these evil companies that still have this very narcissistic idea about themselves. And I don't mean that our industry is bad. I mean that we need to redefine the narrative. And I think computer science especially, it needs utopian fiction. We need to start painting a future and using imagination to show a different kind of a world. Because technology doesn't happen in a vacuum. As I mentioned, computers didn't fall from the sky. They were built by people with different worldviews and value systems. And when we think about the history of technology, we can see kind of two different waves. The first wave of computers happened after the Second World War with a very specific cultural setting. And the second wave of computers happened in the late 70s and early 80s in Northern California when the PC and the Macintosh were born. And that was an era of huge optimism for humankind. We had man to the moon mission, we had the civil rights movement, we had the LSD and the hippie movement happening. And that is kind of the cultural ecosystem where computers were born. But now when I look at our children, they are the Greta Thunberg generation, the generation that is really angry, really frustrated, and really fearful. And I worry a lot about what kind of technology will this generation build for the next 30 or 40 years. Will they only take our fears and reflect them, or will they be able to create a new kind of future? So when parents ask me what should I be teaching to my children when it comes to technology and how many minutes should they be spending in front of a screen a day, I say I wish it was that easy. But it all comes back to teaching children curiosity, understanding that the world is not ready yet, that there's so much we haven't discovered or invented. I want them to be fearless and teach fearlessness when it comes to technology, that I too can break this thing apart and tinker and twist it, and I can have agency and influence over the world. And I want them to learn wonder, to be able to ask the big questions that we as adults are too afraid to ask. So I'm going to end with a story. A few months ago, I read an article on The Guardian where there were a bunch of Cambridge University researchers who were showing children two sets of pictures. One set of the pictures had pictures from the natural world, pictures of trees and animals and plants. And one set of the pictures had Pokemon species, Bulbasaur and Pikachu, and so forth. And by far, the children were so much better at recognizing the Pokemon. They had more language to describe the Pokemon than the natural world where they were living in. And the researchers were really worried because what happens to our ability to operate in a democratic world when we don't have language to describe it? Humanity and language go so much hand in hand that we need to be able to describe our world. And I'm worried about that future too. I want my children to grow up in a world where they have language to describe the badger, not the Bulbasaur, the birch tree, not the Pikachu. But I think it goes beyond natural world. We are losing our vocabulary when it comes to technology as well. So many of the words we as technologists throw around here today, like the blockchain, Bitcoin, the algorithm, machine learning, are like suitcase words. They are words we use like suitcase. We throw them from one person to another, and we never open and unbox them. And it means that they are not understood, that we don't have agency over our surroundings. And what I wish to see happening in the world of technology is a lot more unpacking of these words. And it requires us to be humble again, because we don't have all the answers, and technology, it keeps changing, and the metaphors and stories we tell need to change too. I had this little boy who once came to me and said, "Linda, is internet a place?" And I tell him, "Oh, no. Internet is this interconnected network globally of servers. You can think of it as the information superhighway. It's like the global village. You can go surfing online." And I feel really good about myself for about 3 seconds when I realized that, oh shit, I sound like a kid of the 1990s. This child, he has never pressed the disconnect button of the modem before. For him, the internet is something invisible everywhere around him. And I need to start updating my metaphors really, really quickly. So when I talk about the internet, should I talk about the fiber optic cables that go from the bottom of the sea all the way to space? Or the server farms that store data about us, our friendships, our families, our democracies? Or should I talk about the data, about the protocols and software that define how that data travels around the world 8 times in a second? Or should I talk about the explosion of creativity, of cat videos, of Gangnam styles, of funny memes that happen when 4 billion of us can finally have a conversation together? And I think this is the challenge of teaching technology for the next generation. We can't only focus on the hardware side of things. We can't only focus on the software side of things. And we can't only focus on the societal impact technology is having. We need to teach all these 3 things together, and we need to do it quite quickly. Finally, the stories we tell about technology, they shape the way we see the world. We all have childhood stories that have shaped the way we understand our own position in the world, that keep influencing the way we see the world. And the stories we tell about the world of technology, they matter. There's this tiny Italian village called Reggio Emilia that was faced with a similar situation we're facing right now, today, in this day and age. After the Second World War, they realized that the fascism and all of the turmoil of the war had completely destroyed a generation of children and their future hopes. And they decided that they are going to write a completely new kind of early childhood arts curriculum in the 1950s. But instead of doing a strategy paper, instead of writing a vision paper, the founders of this movement, they wrote a poem. And it's called The 100 Languages of the Child. And they state that the child has 100 languages to express themselves. The language of writing and reading for sure, but also the language of singing and dancing and sculpting and drawing. And they say that the science and imagination, they are not the opposites. Neither are reality and fantasy. They all belong together. And I think if Loris Malaguzzi lived today, he would consider computer science as one of the 100 languages. And this is where I want to end up with. Those languages really matter, and who speaks them really matters. But ultimately and in the end, technology, it's built on us humans. It's not a binary difference. It's not the computers versus the humans. It's us all together. Because after all, the very first computers were humans. And actually, they were not humans. They were women. The very first computers were women who were calculating ballistic curves in the ENIAC computer after the second or during the Second World War. We called them computers like we call nowadays nurses, or doctors. And in some ways, I think the very last computers will again be human. And technology is an interesting word. It comes from ancient Greek. And the Greeks said that technology is the tools needed to do the job. But in addition to tools, they stated that technology is about the skills and competencies alongside those tools, very human abilities that we bring into the problem-solving equation. That means the Greek thought that agriculture is technology, that democracy is a technology. And I think we need to start having this idea of technology. So I'm going to leave you with a new definition of technology I personally really love. And it comes from an 8-year-old little girl. And it was the English school in Helsinki, and I asked the whole classroom of kids to give me a definition of technology. What is technology? Who uses technology? And what is it used for? And this was my favorite one. It's a 9-year-old girl, as mentioned, who says that technology is electricity that loves. I'm just going to repeat that because that is the most poetic explanation of technology you will ever hear. Technology is electricity that loves. It is used to play. I use it to have a conversation with my mom. We use a WhatsApp application. And finally, and most importantly, people uses technology. Thank you very much.